Right, so we have waited for all of you who were maybe a little bit late. So once again, welcome to the webinar, Concentrated Solar Heat Solutions available for carbon-free industrial heat and steam generation. So today we'll have three expert speakers. So first we'll have Siddharth Malik from Megawatt Solutions. Siddharth, could you tell us where you're joining us from?
New Delhi, India.
Thank you, Siddharth. And thank you, Siddharth. Then next up, we'll have Safir Wahid from Z Solar. Safir, where are you joining us from?
Hi, Carlos. I'm joining you from Lahore, Pakistan today.
Thank you. And finally, we'll have Svante Bungard, CEO of Alberg CSP. So Svante, please, where are you joining the webinar today?
Yes, hello. I'm joining the webinar from Dubai, where I'm on one of the global trips. Busy times right now in solar energy. Hello, everybody.
Great, thank you, Svante. So, right, as you see, a very international lineup of speakers we have here, and all of these guys are pioneers in the concentrated solar heat industry. So you'll hear all the latest information. So we'll start with our first presentation, which is first presenter, which is Siddharth. Siddharth, could you please share your presentation? And in the meantime, I just wanted to let all of our attendees know a few housekeeping things. So you will get the presentations a couple of days later, and also please ask questions. We like questions, so you'll see at the bottom of your toolbar you'll see a Q&A box where you can pose your questions. Also, we have this custom here. Tell us where you're actually joining us from today in the chat box, and there you can interact with other attendees as well. Well, over to you, Siddharth.
Thank you, Carlos. And a very warm welcome to all attendees and the panelists. Pleasure to be here. Concentrated solar heating for industrial process heating and steam generation. Absolutely, I think it's a very, very pertinent topic. And I'm sure everybody's joining from various different parts of industries and academia. So my warm welcome to everyone. Just about us, I represent Megawatt Solutions Private Limited, which is a company based out of New Delhi, India, a core technology and solutions company that I founded about 7 years ago. And the intent was to provide clean and emissions-free heat to industries and manufacturing companies. So consequently, our focus was on industrial manufacturing plants, consumers, a bit of commercial as well. And we very quickly realized early on in our journey that unlike photovoltaics, this is a very, very interestingly complicated affair. So it requires a very different approach rather than a typical PV EPC approach. So that way we are positioned as a turnkey solution provider. What that means is right all the way from design, detail engineering, we have our own manufacturing facilities for everything that we provide. We install, operate, commission, and also then undertake comprehensive operation and maintenance contracts for about 10 to 15-year periods. We started out in India and have a pan-India presence for both projects and services. We've also now ventured out to parts of Middle East and Southeast Asia. And that's also a very, very interesting marketplace for concentrated solar thermal. As on date in India, we have roughly about more than, well, this figure is slightly old, but more than about 50,000 square meters of cumulative installed base across India. Now, I'll just put that number in perspective. When you look at installation of solar thermal in industries, one is largely limited by the amount of land area or rooftop area that is available. And this number is, while it seems dwarfed in terms of PV capacity, for on-site industrial solar thermal, it's one of the largest installations, at least in India, probably Asia as well, I'm not quite sure. We're currently geared up for a manufacturing capability to deliver more than 200 megawatt thermal of solutions or systems per year. That's a brief about us. And now I'm going to just quickly cut the chase and get into the heart of the system. The solution is called Megawatt Solutions Solar Field, MWS Solar Field. And we believe that we're literally redefining how industries look at generating and consuming heat for a variety of applications, of course. Concentrated solar thermal has been around for a while, all the way back to probably Archimedes. So that needs no introduction. But the idea that one can focus the incoming energy to achieve very high temperatures, the idea that radiative heat transfer mechanisms are very well known in the industry, such as boilers and heaters. And last but not the least, the idea that even sunflowers move or track with the sun to maximize the incoming energy. We put all these very interesting concepts together, and ultimately we looked at nature, and everything we do proudly so is inspired by nature. So Face the Sun, that was one of the key principles that we walked away from, looking at nature. And consequently, we developed the Megawatt Solutions Paraboloid Dish Concentrator, largely for providing heat and reducing fossil fuel consumption in industries. The paraboloid dish comes in various different sizes. Of course, the principle is pretty much the same. There is a collection of mirrors in a paraboloid shape, where the incoming energy gets concentrated onto a central receiver focal point, which is the thermal receiver. It's just like a boiler, except that the flame is solar flux flame, unlike a fossil fuel flame. The stagnation temperatures at this focal plane can go north of 2000 degrees Celsius. That implies very, very high temperature capability and very high efficiencies as well. What you see on the top at the center point of the paraboloid dish is a thermal receiver, which increases the temperature of the incoming fluid. That fluid could be pressurized hot water, steam, thermic oil, hot air, pretty much any working fluid that's used in industries today. And then that is brought down through pipe and piping networks to be taken to the end point or the use point of in the industry. This is a modular unit. It tracks the sun in 2 axes, just like a satellite dish, in order to always ensure that the source, which is the sun, the reflector, the dish, and the receiver are always aligned. Doesn't matter, it's summer, winter, different season, different times of the day, of the year, year after year. The system ensures that all of the energy that falls onto the concentrator is maximized compared to any other thing that's out there today, and consequently achieves an efficiency which is north of 85% thermal. That implies more than 80% of the energy coming into the dish, it actually gets translated into the working fluid. So it's heat in, heat out. It's essentially a heat exchange, unlike a PV, which is a conversion of energy. Hence, these systems are very, very highly efficient, just like a heat exchanger. That's the dish, which occupies a footprint of 1 meter by 1 meter on ground, while the dish size is roughly about 100 square meters. So that's about 12 meter to more than 12 meters in diameter. And the system, of course, it's an automatic tracking system, whereby post-commissioning, it does not have any requirements of north-south land requirements. You can plant it anywhere, and the system figures out where the sun is and latches onto it and does this exercise all day and all evening long, all year long. It's a modular system, and these systems, as shown on the top right, are added in series and parallel combinations to ultimately arrive at the temperature and the quantity and the quality of heat that is required. So ultimately, we add the paraboloid dish concentrator. We complete the process integration and automation into the customer circuit. We design the instrumentation piping network, and we deliver heat, which can be utilized for a variety of purposes, be it process heat, cooling, air conditioning, power generation, of course, and other ancillary applications such as desalination, evaporation, dehydration, drying, etc., etc. The list is practically endless in the industry. Now we recognize that when integrating into an existing manufacturing plant, the industrial process is the cash cow of the company, and there's a lot of reservation in terms of tinkering with it. That's the reason we are very, very conscious that the solar thermal system, the Megawatt Solution solar field, when added on to an existing industrial utility, is done in a very, very seamless manner so as to not disturb the end process. We do it both direct and indirect integrations, which require heat exchangers. And by this simple concept, both the solar field and the fossil fuel work in tandem, thereby requiring practically no human intervention to switch off when the solar is not available, and so on and so forth. Based on this simple principle, we provide systems with and without thermal storage, and we work across a variety of industries as is listed on the slide, across different working fluids, across a variety of temperature ranges. One of the most unique things about paraboloid dish concentrator is very high efficiencies at very high temperatures. Unlike parabolic troughs, just a quick note on paraboloid dishes, which may or may not suffer with end losses and have an interesting land requirement. A paraboloid dish stands high above the ground, has a very, very small footprint. So that's a 100 square meter dish with a footprint of less than 1 square meter on ground, which for industries is very, very important given the lack of space that is mostly available in industries. Here's an example, for instance, where a solar field consisting of dishes is spread across wherever area is available next to a sludge drying system, thereby making or allowing paraboloid dishes to be installed where conventional concentrators may or may not be able to get installed. Of course, last but not the least, paraboloid dishes, due to a very high concentration ratio, have a very high efficiency across a wide temperature range, which may or may not be true for a lot of other concentrating technologies. We recognize that land areas are always not available, hence rooftops, RCC or reinforced concrete rooftops also take advantage of our smaller 20 square meter paraboloid dish, which has all the same principle: 2-axis tracking, safeties, very high efficiency, high reflectivities, but it's meant for installation on rooftops without using any cranes. So it's almost like a do-it-yourself kind of a kit that allows penetration of concentrated solar thermal into industries both with and without land. So here, I think over the next few slides, I'm just going to run through a couple of projects that we've done in India and established a leadership in this market. Here's a paraboloid dish concentrator rooftop mounted solar field, which generates steam for reducing fuel in a dairy industry, which uses a lot of steam for CIP and pasteurization kind of applications. Dairy, pharmaceutical industries, which use hot water, pressurized hot water, steam. Top right, we generate hot air up to more than 220 degrees Celsius, which is widely used in food, textile, and even interestingly, wastewater evaporation and sludge drying applications that we are pioneering in India. Thermic oil heating for the rubber and the chemical and the polymer industries. And last but not the least, a very common application which is used very widely, which is boiler feed water heating. So just to run through on a few of the interesting projects, Mother Dairy is one of the largest dairy industries in India, and we install a system which is about 40 lakh kilocalories per day. As you can see, a modular units free up the ground space, and the systems are added in series and parallel combination. And this system has been operating for almost more than 4 years and already has paid back itself within 3 years. So for the next 25 years, the customer looks forward to practically zero OPEX, clean and emissions-free heat.
Siddharth, sorry to interrupt you, but we need to wrap up now because we're running out of time.
Okay, sure. So I'm just going to quickly run, I think probably take another half a minute if you don't mind, and just run through a couple of slides. The point is just to make you understand that paraboloid dishes are out there. These are not R&D projects. These are commercial products used very widely across local and international companies. And we look forward to participating with all of you to make sure how we can help reduce your fossil fuel consumption in industries. Last but not the least, very, very attractive LCOE in terms of dollar per megawatt hour thermal compared to any other fossil fuel used in industries. So thank you very much. And as I say, face the sun, feel the heat. That's the way to go. Thank you again.
Thank you, Siddharth. It's a very, very interesting presentation. And we already have a couple of questions being lined up in the Q&A box. So if you have time to respond them, that'd be great. Otherwise, we'll answer questions at the end. So please, to all attendees, do post your questions. So our next speaker is Zafir Wahid. Zafir, sharing his screen, and well, over to you.
Hi, Carlos. Thanks. My name is Zafir. I'm the founder and CEO of Zed Solar. We're also a CSP company with its own technology based in parabolic sun dishes. So some similarities with the system which Siddharth was talking about earlier on. So we really look at parabolic sun dishes as a CSP 2.0 because they have several advantages, primarily being very high efficiency levels, and unlocked at the right costs. They can really make a big shift down in costs for heat and for power. So let me just I'll give you a quick background about Zed Solar. We started off our solar projects within one of our sister companies, which is an engineering company, back in 2008. Since then, we have done projects in Pakistan. We've installed systems in Sweden, in the UAE, in Kuwait, and also now working in Oman. And in the past few years, we spun off the company or the activities from A Design into Zed Solar, which is a standalone company now, focusing on providing turnkey solutions for solar process heat primarily. We have a strong technical team. This comes as a result of ourselves being a technology company, having developed our own technology. And it's a diverse team which covers all the areas, not just the concentrator or the solar field, but also the civil works and the piping and the control systems, which allows us to be able to offer a full turnkey solution. So moving on to the system, our dish looks a little bit different to the previous dish. It's actually a patented system. It's a, let's say, an umbrella structure, which is very light and cost effective. And it's not only easy to produce, but it's also easy to transport and install and commission, which basically gives us a big advantage. Our focus areas on the industrial process steam areas, solar thermal enhanced oil recovery, which is a huge area, desalination. And then, of course, lastly, but not least, is power generation with thermal storage. A quick overview of a picture of some of the projects in Pakistan, in Dubai. The one in Dubai is at the Mohammed bin Rashid Solar Park. It's a 10-dish system, and it can work both in power and also in heat. So moving back to what I'd said earlier about CSP 2.0, parabolic sun dishes being CSP 2.0. Why do we believe that, and why is the case? Well, number one, we have an ultra-high net solar to thermal conversion efficiency of 88%. This is actually the net solar power coming in, and 88% of that is going out in heat at the exit of the park, of the solar field. And this is proven and documented in several technical papers of ours published by the American Institute of Physics and presented at Solar Paces. This high efficiency is our starting point, and it also means that we can be effective, we can be commercially competitive with gas-fired systems as well because of this high efficiency level. The system was designed for operating in the desert in harsh environments, and over the many years, we have proven ourselves that the systems can operate in deserts, they can operate in Nordic freezing climates, so it's a very robust system. The advantages of having a parabolic dishes is that since each parabolic dish has a very high sun concentration ratio, typically about an average sun concentration of 2,500, it means that each parabolic dish can generate the required steam conditions. So therefore, if you have a field with 100 dishes, if one fails, you only have a single dish going down, and the rest of the solar field can keep on operating. So it's a decentralized system, which brings a lot of robustness, and also reduces the construction time of the CSP field, and allowing it to come on sequentially, which is a big topic as well in CSP system generally. Furthermore, we also have an inbuilt and automated self-cleaning system on each unit. Cleaning is obviously a big factor, especially in areas of high soiling, such as the Middle East, where you can have 1% or more soiling per day. So the system cleans itself, and also it uses very little water, typically 1/10 the water of other automated systems for other technologies. And it's also for industry, it's a semi-mobile design. Since each concentrator is mounted on its own foundation, it can actually be moved as well. So if it needs to be moved after 5 or 10 years, that is actually possible. So when I talk about 88%, just very quickly, I mean, it's a figure which people might raise an eyebrow to. So we just actually show how we achieve it. If you look at the 4 images on the bottom, we have 100% of the solar energy coming in incident on the dish. 95.1% of this gets reflected back into the thermal receiver, of which 99.3% enters the receiver. And then 92.4% of this is converted into heat. And that's how, at the end of the day, with all these different 3 processes, we get 88% net solar to steam at 320 degrees Celsius. So the efficiency is maintained at operation relevant temperatures. As I mentioned, the efficiency level is high of dishes, especially at high temperatures. So if we look at the top left graph, it's a very flat efficiency curve. So where we are about 88% efficient at 320 degrees Celsius, the efficiency is still over 85% at 600 degrees Celsius. So that's a unique advantage that a cavity type receiver can maintain. And then this efficiency level also means that we have a very nice and smooth power output curve. The curve at the bottom right is actually a real data from Kuwait. It shows that the system starts up fairly early, ramps up to over 80% of its operational capacity, and stays there for the bulk of the day. So we see about 8.5 hours, the system is producing over 80% of its rated capacity. And that allows you to use the system, use that energy and use that power very easily. Especially if it's a hybrid system where in an industry you have, for example, gas-fired boilers which might be running at night and solar taking over in the day. It's very easy to mesh both of them and make them work together. Quickly looking at the efficiency comparison, if we look at the bar charts on the left, we have central tower parabolic and dish thermal. If we look at the bulk of the efficiency gain, it's in the solar collector optical efficiency. One of the main reasons for this is that the parabolic concentrator is the best shape. It's the optimal shape to reflect and to collect the sun's energy. The Mesopotamians knew about this 6,000 years ago. The other big advantage is that it's a dual axis tracking system. So there are no cosine losses throughout the year as the angle of the sun changes. And then the second thing is we have the receiver thermal efficiency. Because we have a cavity type receiver, there's only one small opening in the receiver. And that's also at it's face down when it's operating. So the losses of the receiver are very low. So these 2 factors really help to give the very high overall net annual average efficiencies that a parabolic sun dish can achieve. So if we look at the right side, that is the net average annual efficiency. And there's no variation on that. So with a parabolic trough, for example, you would have higher efficiencies when the sun is directly overhead, but much lower efficiencies throughout the other seasons. That is not the case with the parabolic sun dishes. Now, land is very, very key in industry, in an oil field, for example. So the parabolic sun dish, again, is very, very efficient when it comes to land utilization. Firstly, it's a modular system, so we can really adjust the amount of land we're using. If you look at the different images, you can see how much energy one solar inverter produces and in compared to the other parabolic and trough. So you can just visually see there's a big difference there. So land requirement is less, and then also mirror area is very low because of the high efficiency levels. And then when we combine the automated cleaning system, which is very water efficient, so typically we use about 50 milliliters of water per square meter to clean, and you combine that with the lower mirror area, you get a massive reduction in water that's required to clean the system and keep it operating at peak power. So as I said, the systems have been through different conditions. We've had gusting windstorms, sandstorms in Dubai. We withstood several winter deep freeze cycles in Sweden, which are actually quite harsh, the freeze-thaw cycles. So the system has proven that it can withstand real-world environment. And then, as I mentioned, we are a turnkey solution provider. So we have developed all the different areas. Parabolic sun dishes being maybe not so mainstream historically. We've had to develop different areas to be able to provide a turnkey solution. So that includes the concentrator and the receiver, which is the energy absorber. It's the automatic cleaning system. Then it's the park level integration and control system. We have a special system by which we regulate the pressures within the park without having to put instrumentation and control systems on each dish, which is a big advantage in reducing cost and increasing robustness. So, for example, you can have one pump and one control system to control the steam generation from 72 dishes instead of having it individually. We have our own steam quality control system, which is a feed forward and a feedback system. And so we can maintain steam quality throughout the day with a fluctuation of about 1.5 to 2% maximum. We have our own sun tracking system. And then our other technologies like alignment and production know-how and field installation, that's all been designed over the years to make our system real-world compliant. Just a quick overview. It's a fairly straightforward system to put together. The main components being the panels, they're made in their factory produced basically. So the optical accuracy is already guaranteed. And on site, it's a fairly straightforward process to put them up. So we've won some awards, been finalists for other awards, CSP Today Supplier Award in Spain, Platts Global Energy Finalist. We have several papers which have been published. On the image on the right is something we're very proud of. It's His Highness Sheikh Mohammed, the ruler of Dubai, launching a very big initiative. And that was also with our system, with our park in Dubai that he chose to announce that. That's from his Twitter account on the right side. And then just in a summary, what are the advantages of our system over not just what we'd say dirty heat, over heat generated by gas or by coal or by diesel, but also over CSP technologies. The headline figure being the 88% net solar to thermal conversion efficiency. But the breakdown being we're about 35% more efficient than other CSP technologies, which means the solar field size comes down by 33%. When the solar field size comes down by 33%, combined with our efficient production installation, the capex falls by about 55%. The O&M falls by about 70% and land use by 35%. And that's really how we have a big advantage over traditional CSP technology, and that's why we call ourselves CSP 2.0. Yeah, so that was a quick overview of Zed Solar, where we are, what our technology is, what we've been through. And I'll hand over to Carlos to move on to the next presentation. Thank you.
Thank you very much, Zafir, and very interesting presentation. Good questions coming through, which we'll read at the end. And next we'll have Svante Bungard from Aalborg CSP. Svante, please, when you're ready, share your screen and
Hey everybody, nice to have so many interesting questions coming up. I'm keeping busy with this. I'm just trying to get this technology to work. All right, here. Let's try this.
So if you go to the bottom toolbar in the middle,
All
there you go, you've got it.
All right. All right, good. So, thank you also, Siddharth and Sophia, for those interesting presentations. It does seem that the dish technology is moving forward rapidly and is a viable proposal for this market. So I would say, like, from an introduction point of view, Aalborg's approach as a company to this is very different from the two other presentations. These guys are very qualified, I can see, OEMs, original equipment manufacturer, who make dishes and also will install and EPC and other things. But in the end, it's a technology that they are basing themselves on. The product here. Aalborg's approach is opposite. We are technology agnostic. We do not care what generates the heat. What we do is we design systems and integration of systems and how they can work in co-generating together with either fossil fuel or other requirements or existing boiler systems. And we normally use, as again, proven solution for this. So you will see different technologies in my presentation if I get through it all. Both tower, as we're looking at now, the biggest solar thermal project we've done today, 50,000 square meters of mirrors here. In Australia, co-generating hybrid solution using both fossil and tower together, producing both power, desalinated fresh water and heating for a greenhouse operation. I'll come back to the details. Also, we'll get into parabolic trough, which we're using. We're also using flat panel technology because basically the only question that's relevant is this commercially feasible or not? That is going to decide whether or not there'll be a project or not. And there was an interesting question from Paul Suskin, which I think we should elevate to the live discussion later on the commercial viability of these technologies. But let me just go into this. I always start all my presentation with this beautiful picture here. Now here, so it's just so interesting to look at the blue fraction here, annual solar energy consumption, and this is the total fossil fuel reserves here: coal, natural gas, oil. This is the big cubicle, the solar energy received in a year, and this just means that we just have to hurry up, then we'll make very good solar solutions for both thermal and power. Same slide in a different context. Electricity demand in the world would be covered by CSP in this part of the Saharan desert. So we just have to solve the question how. And this is Aalborg's mission, and I always have this slide where we want to lower the cost of energy, and we do that by making more competitive green energy solutions. And if Siddharth and Sophia has something new numbers to show, we can discuss later on the is again levelized cost of energy or heat in this matter. Then definitely we would like to also consider using their product if that's available for others. But let me continue just giving the introduction to Aalborg. Aalborg is a multi-disciplinary company, engineering and technology company, which focus on CSP and solar thermal energy. But we focus on, as I said, technology agnostic approach. We are involved in everything. And basically, we're just a boiler company. We just use the solar as the boiler rather than anything else. So we also are involved in CSP power plant technologies and have the experience from this. We're also involved in industrial systems. We're also involved in storage energy systems. We're involved in a lot of R&D projects, looking at what's the next stage of fluids, of technologies, of receiver types, of trough types. So again, a variety of different exposures. But let's go to the interesting part, which is the concentrated solar heating applications. And in our world, it's called integrated energy system. That means that we have multiple sources or multiple revenue streams, I would call them, from an industrial point of view or solar point of view. We do power combined with desalination, or desalination combined with heating, or combined heat and power. Then we have district heating solution. There's a specific market for that in many countries where we have decentralized district heating systems. In Denmark, 60% of all households are covered by district heating. The yearly installed amount of district heating in Denmark from around 2012 to 2017 was 500,000 square meters per year. The biggest solar thermal market for heating solutions in the world. No other market is as big as Denmark in this. Now it has been reduced a bit, the pace of the market, because it's a bit congested. And then we do industrial solar boilers, which is basically the same technologies. It's just applying for steam. So it's more like taking the client view on this. And well, we have proven solutions, which I'll show you at commercial scale, which are operating already and have been operating for several years. And they are ready for market growth. In my view, what is required for the market growth is financing structures similar to what we see in PV and LED, and then structures of these kinds are like operational leases normally, because you can't get a state guaranteed PPA price, and therefore you need a heat purchase agreement which is financially viable. We already now working with leading banks to make financing of multi-million-dollar heating solutions for industrial heat, and this will be happening hopefully within this year, otherwise next year. But this is a market that's going to grow continuously, because that the CSP and these industrial heat solar solutions will just follow what we've seen from PV and LED, where you can just get your solution financed in all cases. So let me move to the first example here. I have 3 project examples. I'll try to speed up. So this was the project which we finished in 2016. It's been producing energy for 1.5 years now. It's 50,000 square meter of mirrors, and greenhouse is 20 hectares, and it produces around 17 million kilos of tomatoes each year, which is sold on a tomato purchase agreement to the Coles supermarket chain in Australia. And this project financing structure has, I think, 10 or 12-year debt financing. The debt interest rate is around 6%. And I think the ROI or the ROI for this project is around 20%. The main investor is KKR Equity House in US based in New York. Just going into the technology is again, this is very simple. We have an energy consumer here, the tomato farm. It is in the desert. And tomatoes in the desert is not a good idea, because tomatoes is actually 80% water content, and that means you need to have a solution. In this case, the solution is that we combine desalination into the plant and use MED technology, multi-effect distilling, to take salt water from the nearby Spencer Bay and then desalinate that to fresh water. The plant is producing every year 250,000 tons of fresh water, in addition to the electricity and heat. So this is almost, the water is almost 50% of the yearly estimated production. But again, it's about designing the system that fits the customer requirement, because the first step is to get the customer happy and to get the lowest cost solution to match the requirements from the customer. Again, just very shortly, excellent resources here in Australia, very good solar DNI, and we have here in Adelaide, north in Spencer Bay in Port Augusta, We have seawater 3 kilometers from the site, and we have a DNI of 2,400 watt per square meters per year. And we have the solar farm just next to the tomatoes. So well, from the idea to reality, we had the full notice to proceed and feasibility study finished in December 14, and then we finished the construction after approximately 15 months, and then commissioning started, and then we finished in 22 months. The concept of this, which also will be shared later, is, well, basically you take the higher grade steam, and this is really not good steam. This is 204 degrees saturated steam. Then we do a pressure reduction of that steam to get it superheated to the turbine, and then the turbine operates, which is included in our scope. It operates and generates electricity. It's only 1.5 megawatt. It's the cheapest turbine on the market, standard turbine, but all the exhaust from the turbine, it goes directly into the thermal storage and is used for desalination. So in that way, you kind of take a step down from the steam grades, and you use the exhaust steam from the steam turbine. You don't have any coolers, anything. You just use the desalination system to cool that further. And then after the desalination, you collect the brine, which is the extract from the desalination, and you extract the energy from that, and you use that for low recovery heat, and combine that with higher temperature heating to service the greenhouse heating demands, which are normally only relevant in the spring and fall and during the winter in nighttime. So if we just look through this short video, here you can see the different parts of the plant already operating. This is fresh water being coming from the desalination unit. Here you have the greenhouse, you have the tower, you have the cold tank or the low temperature tank, and the hot tank. Here, this is the steam blow happening during the start of the commissioning of the project. You have the turbine building and just short of the tanks, and you have the mirrors. Some of them not focusing, but most of them focusing on the tower in this small sequence here. Again, very fast construction, very reliable technology, proven already in many plants around the world. So easy to and the end product, coming out is tomatoes in this sense. So very end-to-end solar to food technology, which is definitely something that we think is feasible to do many other places than just in Australia. So let me see, I need to go to the next slide here. So here's just a summary of this plant, not repeating myself. I'll just go to the next slide. For information, this project was financed completely without any subsidies at all. And the price for tomatoes, which was in the PPA between Coles and Sundrup Farms, was below the market price in Australia, 10-year lock-in of the price. So very interesting in that manner. So if we just go to another example, and this is then CSP for combined heat and power. Here using standard Eurotrough technology, so no magic, no advanced technology solutions, because we normally have an easier time finding the financing solutions when we have more established technologies, which I'm sure some of the challenges with Siddharth and Saphir are facing with their projects. This is a wood chip biomass plant, which is just behind the construction here, which is ongoing, together with a solar field, CSP. It generates hot oil of next slide here. Sorry, this is in Danish, but it's a Danish customer. Next slide. So the CSP generates hot oil of around 330 degrees. It goes to an ORC turbine. The ORC turbine then produces electricity, which goes directly to the grid, and then the exhaust silicon oil from the ORC is then heat exchanged back through the condenser. And then that then is going to be put back into the system and put into a storage tank, and then put back into the solar CSP. The solar CSP is co-generating with a biomass wood chip boiler, which is working together with this and covering most of the winter period, while in the summer it's mainly CSP, because the solar radiation for this plant in Denmark is terrible. It's only around 900 watt per square meters per year. So it's quite poor conditions for solar. But anyway, this is a project which is live and operating now. Here you can see a video which is showing that construction. Here you can see the wood chip boiler already under construction now at this stage of the project. Here the CSP project is already finished and commissioning, and it is around 25,000 square meters. It's 16.6 megawatt thermal peak operation in the Danish conditions because of the poor solar. And using standard concepts and technology, but adapted to industrial scale, because again, the only thing that matters is that we can get to a competitive energy price, and if we can't get to that, no projects will be funded by the banks and the clients in this case.
Sorry to interrupt you, Svante, but we need to wrap up, so we have time to answer questions.
That's perfect. So I'll just skip the rest of this one here. And then the last one is just a hybrid solution. This is now going to, we're just stepping down in temperatures. So this is a 6.8 megawatt thermal capacity plant doing only water. So this is 95 degrees hot water. It takes flat panels, normal unpressurized flat panels, and takes that on to around 50 degrees. And then from 40 degrees to around 70 degrees. And then the CSP boosted up to 95, where both technologies are most efficient. And then it goes to the district heating application. So I'll just skip that video and no need to have any more. So in summary, these solutions are there. They're able to be supported by financing. They are proven in use. Other technologies and collecting technologies like the dish would definitely also be feasible for our projects. Our focus is on the integration of the projects to the client, and making the system and the boiler and the turbine and desalination unit, whatever the client needs, making sure that we serve the client's requirements and have the lowest cost of energy. Then we have a project. Thank you very much.
Well, thank you very much, Svante. So I was going to ask you to stop sharing your screen, which you already have. So great. So quickly, let's go to the round of questions. So one of a few questions that we have unanswered here is the question on financing and PPA. So how do you go about coming to a power purchasing agreement with your clients? Are there any challenges in this regard? Over to you. Let's start with you, Siddharth.
The idea of using solar thermal to displace fossil fuel is actually quite interesting in the industry. We provide solutions in both models, which is the CapEx versus the OpEx as well. So CapEx incurs whereby we come in and install the complete plant, and the ownership of the plant is actually transferred over to the customer post-commissioning. In the OpEx, we actually own and invest in the energy asset in the complete solar field. And we get into a long-term contract called a heat purchase agreement, as my colleague already mentioned, which could be 10 to 15 years, or depending on what makes sense. So we are seeing a lot of interesting innovation in the financial engineering for these plants as well. So that's where we are, at least, right? Both CapEx and OpEx, and it makes a lot of sense in both cases.
Right, makes a lot of sense. Thanks. Would you, Zavir or Svante, would you like to add anything to what Siddharth has just said?
Yeah, I'm happy to also continue the discussion. Again, of course, the interesting question here is what kind of heat price can you get in the projects. So what is the level of pricing that can be attained, and here we need to match the fossil fuel price, as Siddharth is saying. That is what we are replacing. And in our current situation, you know, depending on the solar radiation and the alternative cost that the client has, we are actually able to match this in some markets now, and that's very interesting because that opens the opportunity for third-party financing, not just the technology provider, but actually we have now commercial banks looking at projects for one dairy company or for one meat processing company, which we hope to close later this year. That's at least the schedule right now.
Just to add to that, Carlos, typically what we have seen from our experience is a capital investment pays back anywhere up to 4 to 5 years for our customers. And when we get into an OpEx arrangement with our customers, I think any fuel price which is up to $6 to $7 per MMBTU is something that's very, very competitive for solar. So solar can beat that hands down.
Yeah, I would just like to add, I mean, on the two different models, I think it depends a little bit from the client's perspective and what they prefer. But I think a lot of clients are preferring to go for OpEx these days for an OpEx model. But we are working on deals which are both OpEx and CapEx as of now. I mean, I guess it really depends on the client's perspective and what their priorities for their own capital expenditure and the competition for that is.
Right. So one question that is actually, thank you very much, Safira. And I have one question that is that just came to me when I saw the differing environments in which you develop these projects. So you have projects in India, you have projects in Denmark, you have projects. So are there any limitations in the type of solar resource that you need for a concentrated solar heat project to be viable?
Sorry, the question is to?
Are there any limitations in solar resource?
Yeah. So I mean, CSP differs from PV in that you are talking about the DNI, the direct nominal irradiance, versus the the global horizontal, the GHI. So there could be countries which are quite okay for PV, but they are not that good at all for for CSP, just because there's more haze in the atmosphere or there's more dust in the skies. So obviously it's dependent on the DNI in the region. So you need to have, I would say, ideally above 1750, 1800 DNI to really have a to have a good system, very good cost.
Right, makes sense. Would any of you would like to add to that?
I think it's a very interesting question, right? One is limited by the incoming quantity and the quality of the direct normal insolation, as Zafir pointed out. At the same time, I believe if the cost of the system and the technology is low enough, then even in places where the radiation is not at its best, you can oversize the solar field ultimately to arrive at the same thermal energy. So it's a very strong correlation between cost of the system and the radiation quantity and the quality that is available, which of course varies all over the world. There are much better places like Svante pointed out. And then of course there are places like Denmark with barely 900 watts per meter square. So.
Right. Well, thank you very much. We have a few questions here that haven't been answered, and let me see. So we have a question for Siddharth that it reads, $6 MMBTU seems corresponding to utility scale solar thermal unit. What for small demands? Further, when demand is very low in summer, can you give an idea of the capacity of solar thermal units? So he's asking you about whether you can deliver for small customers, and what about when the heat demand is low?
Interesting. So two very separate questions. One, can we deliver for smaller customers? The smallest we go to is starting about 100 kilowatt thermal, right? I mean, that's a system smaller than that is not probably an industrial grade system, which is how we are structured as a company, strictly B2B industries and commercial. The second point, what happens when the heat demand is low? We provide and offer thermal storage systems whereby the system automatically senses the absence and heat demand of the process and dumps that energy onto a heat storage device. That could be thermic oil storage, PCM, pressurized hot water. It depends on the application type. And then that thermal storage is available to be used in solar as well as non-solar hours. And all of this happens fairly seamlessly.
Right. Well, thank you very much. So, you know, just one last question, and this goes to Svante, and it's, you know, one of my questions, Svante. So, in the tomato purchase agreement idea seems very interesting, and is an application I hadn't seen before. So, do you see any other new or interesting applications you can see for CSH?
Well, I think, you know, there's a seminar, maybe a wake-up call for the developers out there, because I think this is an untapped potential market, and basically we like you hear from the others, have you know, people calling from mining companies, from dairy companies, meat processing, every kind of industry uses thermal power and wants an alternative which can, you know, hedge their long-term pricing, because basically this is a hedging. If you do a 10-year financing or 15-year financing of this, you lock in 50% or 70% or how much it is of your solar energy bills. And this is an opportunity for you as a business to have a stable, predictable cost levels. And this is worth a lot in these days where we again see you know, increasing fossil fuel prices. So it's already there, and we have the first, you know, commercial banks looking at large ticket in the sense of a bucket of financing for $250 million, which is only going to be used for solar thermal projects or CSH solutions. And again, it's just going out there to grab them and get the structure. There's no different from PV, LED, or what we see in other industries. Thank you.
Well, thank you very much. Any parting words from you, Siddharth, Zafir?
Well, first of all, it's been a pleasure to be in the company of Zafir, Svante, and all the people that we cannot see behind the screen. Just personal thanks for attending something which is of tremendous interest to the emerging global community. I thank everybody for their time.
Yeah, just like to thank all the participants. I hope what was into you and that you know, we were able to answer your questions, and I hope also increase your interest or knowledge about our areas of operations and expertise. Thanks.
Well, thank you to all participants and all the speakers. Thank you to you, Siddharth, Zafir, and Svante. And just to remind attendees that you will get the presentations and the recording of this webinar within the next 2 or 3 days. And we hope that you join us in other webinars we hold as well. We have a bunch of them coming up this month, which you could check at our website and at insights.com. And also we have in the MENA CSP Keep you know, more webinars and activities coming up. So well, thank you very much for everything, and hopefully see you soon in our other webinars. Bye.
Ciao. Thank you.